Okay, this one we're given a circuit with three voltage sources. We have an 8-volt source, we have a 12-volt source, and then those are independent, and then we have a dependent, current-dependent voltage source, 3ix, where ix is defined in this leg. And we're asked to use superposition to determine the voltage VAB in here. So this one could be maybe a little bit tricky, but let's see how we would apply that here. So the first one we want to consider then is we're going to keep the 8-volt source, find the contribution from the 8-volt source. So remember, when we do that, if there's other voltage sources, then we must short those out. So this 12-volt source then we're going to treat as if it has been shorted. So this is our new circuit. And we now see that we have this loop here. We're gonna do source transformation here and simplify this a little bit. So when we do that, this part right here, we can redraw then as, remember when we do source transformation, we can change that to a current source, and then that's going to be divided by the resistance, so that'll be 3ix over 6, which that's just going to be ix over 2. And then that's going to be in parallel with the original resistor, which was 6 ohms. And then we draw the bottom 6 ohms. It's going to stay in place right there. And so we see now that we have 6 and 6 in parallel, so we can rewrite that then. So then this will again be the current source, and that's going to be ix over 2. But now it's just in parallel with a 3 ohm resistor. And so then we can take that and do source transformation back. And when we do, remember that puts this back in series, 3 ohms, and then our new source is going to go back to this dependent source, and it's going to be plus sign this way, be 3/2 ix. So everything you see in the red here will be replaced by this right here. So we just did source transformation. We transformed this part, which gave us this top part here. We took into account the parallel resistances, and then we transformed it back. And so we can now redraw that circuit so that we can do analysis on it. Let me get this done. So this whole red portion here goes away, and let's just draw that so hopefully it'll be a little clearer to see. So now we're just saying that this is all gone, and we're just gonna have one branch now that's going to be, so I'll do it in red. So this is our 3 ohm resistor now. Oops, let me use the right line weight. 3 ohm resistor. And we'll have this dependent voltage source here, which will be 3 over 2 ix. So now we just have a loop. So that being the case, we can now write the loop equation. So let me make sure you know where we are here. So now we can write the loop equation, and when we do that, we see that ix is the current flowing around the loop now. It goes all the way around the loop. So everything's in terms of ix. So now we have our 5 ohm resistor, so that'll be 5ix. Then we have our 2 ohm resistor, it's going to be 2ix. We have our 8-volt source. We hit the negative sign first, so that's -8. Then we have this 3 ohm resistor, so that's going to be plus 3ix. And then we have our dependent voltage source, so again we hit the minus sign first, so that's -3/2 ix. And that gets us back to where we started, the 5 ohm resistor, so that's going to equal to 0. And so this is one equation, one unknown. So when we solve that, we come up with an ix that's equal to 16/17 amps. And so we also know that VAB, we'll call this number 1 right here, that's what we're looking for, that by Ohm's law, it's just going to be IR. Well, in this case, the I is IX, so that's 16/17, and the R is the 5 ohm resistor, so that's times 5. And so with that, we'll get 80/17. So that's the voltage drop when we just consider the 8-volt source. Okay, so now let's reset our circuit here, so we don't need any of this anymore. And now we're going to consider the 12-volt source. So if we do that, let's draw a quick line here to make sure we can see where things are separate. So now we'll come back and we'll consider the 12-volt source. So again, we need to short out the other voltage supply. So that means this 8-volt source is now gone. And so we can replace that with that. And so now we want to do another source transformation to try to simplify things again. So to do that, let's come back over here. Again, we're looking at this portion here between these two nodes, the top part. So when I do the source transformation, the top part, again, is going to be a current source. It's going this way. And so 3 divided by 6, that's going to be 1/2 ix. And that's going to be in parallel with the 6 ohm resistor. And then the bottom part, 12 divided by 6 is 2, so that'll be another current source. Draw that a little neater. Have another current source, again going that direction, that'll be a 2 amp current source. Again, that's in parallel with the 6 ohm resistor. So in this case, the parallel current sources can be combined and the parallel resistances can be combined. So when we do that, we will have the 2 and the 1/2 combined. So that'll give us a current source here of 2.5. And then our resistances, which are in parallel, will be 3. 3 ohm resistor is there. Okay, and so now we can transform that back, and when we do, we can break back out we can write this again as another current source here. This is the 2, and this is the 1/2. And so when we write that back out and multiply it back out, what we'll have then is the 3 ohm resistor. We'll have 2 times 3 is 6 volts, so our 6-volt supply. And then we'll have our dependent source. again in the same direction. That's going to be 3 halves, so 3 times a half is 3 halves, Ix. So now what we show in blue up here can be replaced by this right here. So let's do that. Let's make things a little simpler. So we'll come back and erase this. And what we're saying then is that we can now get rid of all of this. Takes just a second. And now we have, remember this other one. So now what we have in blue, we'll have this 3 ohm resistor. And then we have a 6 volt source. Then we have this dependent volt source again. I didn't draw that very neatly. Right here, and again, that's plus direction 3 halves Ix. So just as before, we've got a single loop with Ix being the current flowing through everything. So we can write our equation again as we did before. We can start at this point here. So we come down, it's our 5 ohm resistor times Ix. And then that'll be plus our 2 ohm resistor Ix. And then we come around, we have our 3 ohm resistor times Ix. Then we have a minus 6 because we hit the minus sign first. Then we have a minus 3 halves Ix. So hit the minus sign first. And that gets us back to where we started, so we can set that equal to 0. So just as before, we have one equation, one unknown. So when we solve for Ix in this case, again, we should have called this Ix1, so we'll call this Ix2. That's going to be 12 over 17 amps. And again, VAB is just IR. Again, where I is our Ix. So in this case, it's 12 over 17. This will be from the second source. And then that's times our resistance, which is 5. And so we're left with 60 over 17 volts. So then to get our total VAB, we'll just add our VAB1 and our VAB from source 2. And so that's going to give us 80 over 17 plus 60 over 17, and that is 140 over 17 volts. So that is the voltage from A to B from our original circuit, solved for using superposition.